Okay, let's get started. Welcome to my talk, Prompt Build Repeat, the vibe coding mindset. And first things first, please don't take the first part serious. Let's get that vibe coding, because it's really cool. I want to start a new business. So this is my idea, because I'm an AI influencer. I want to create a social media application that helps me to, of course, use AI to generate my social media posts. So I want to use the Perplexity API for researching and the ChatGPT API for generating the posts. Of course, I also want to have user authentication and persistence in a database. Okay, so let's get started. So I created this application before I went over here to the venue. It's called the, the social media generator. Yeah, it looks cool. And now I can generate social media posts by clicking this button here. And for example, I want to generate a post about the Angular MCP server, since this feature was added 2 weeks ago to the Angular CLI to demonstrate that Perplexity is working. I want to generate it for LinkedIn. I want to have it informative. I click generate, and then I have to wait a few seconds. So what is the cool thing about this platform? It's called Lovable. Maybe you heard of that platform. So with Lovable, you can generate vibe code, fully working applications. So they use React in the front end. And the cool thing is with Lovable, you can also use Supabase in the back end. So Supabase is like Firebase, but with the help of open source solutions. So they use Postgres, so you have authentication, cloud functions, and so on. But now we have our post generated. We can see here the sources used by Perplexity. We can also see the post generated, so it looks also fine. Yeah, great. Okay, now let's go over to YouTube and create one of those videos. Now I'm a millionaire maybe, so I start selling my application and reaching 5 million ARR in a few weeks or 7 million, and I don't know. Yeah, you can see, there are more and more of those videos. We can also find posts about this on Reddit, of course. So when you go over to Reddit or x.com, and you can see there are much more millionaires now out from nowhere since the help of AI tools. So really cool. So let's take this more serious. And first I'd like to introduce myself. So my name is Daniel Sogl. I'm from Germany, 29 years old. Currently working at a company called ThinkTecture AG. So we're doing normally classic consulting. So we're doing Angular development and backend development with .NET. But we're also working with generative AI projects. I recently got promoted to an MVP a month ago for Microsoft. It's really cool in the topics of developer and web technologies, since I'm talking a lot about front-end development with Angular and also with AI coding using Copilot. So what is this talk about and what is this talk not about? So it's called the vibe coding mindset, but you will see that I have a critical view about this topic. So our journey is about, we discover how we can set up a working AI coding environment. So what you have to take a look at and which tools you can use, for example. And this should help you then to write or generate production-ready code. And this talk is not about fall for the claims the vendor are doing. So we will later also take a look into those numbers, what they are claiming, how much more productivity you gain using AI tools. And I'm also not here to pretend that vibe coding works for a production-ready system. So sorry about that. But let's see. So there's a currently, I call it revolution, a vibe coding or AI coding revolution. So when we take a look into numbers, there are so many AI tools out there reaching more evaluation. For example, Cursor reached $2.5 billion. Maybe you heard of this thing that OpenAI wanted to require Windsurf for $3 billion. 50,000 organizations are already using GitHub Copilot, and based on the sources, 40% of the code is already generated by AI. Okay, but what I really like about this topic is this GitHub CEO say is the path to 1 billion developers. because we are democratizing now technology with the help of AI. And my favorite example is, and this is not a joke, my grandpa is 75 years old, and he recently started developing Python applications for his home network and smart home using ChatGPT. So he did not ask me how to do this, he discovered it by himself. So this is really cool to see that now more and more people can use those tools to create applications, to create code. But of course this comes with a downside, and I also like to talk about that. First, let's take a look into this term vibe coding. So it's a new thing, of course. So it was formed by Andrew Carpathy this year. So here you can see his original tweet. In the interesting part here is the first sentence. Vibe coding is about forget that code even exists. And I assume that you all here are software developers and not just vibe coders, that code does not interested in you. I think code is interesting for us. So this is why I also like to talk about the vibe coding spectrum. So we don't ending here, because for me personally, vibe coding is more a meme than something practical. At the end, you're ending here with this picture. There was also a podcast, not sure if it was a windsurf podcast or from Cursor. And in this podcast, they were really hyped about this thing that they can ask the AI over and over again, fix it, fix it, fix it. And after 20 iterations, it finally was able to solve the bug. Okay, cool story, but I think this is not really practical. So when I call about vibe coding, for me there are three, it's a spectrum, and there are three categories. And the first category is the simplest workflow when using AI to enhance your work as software developer. For me, is the AI type assistance. So when you use Copilot or Cursor or whatever, and you start typing, then you can see normally this ghost text, called ghost text. You can accept to use this generated code to complete your function you started to type on, for example. This is the simplest one. The next step or stage will be AI pair programming. And this is the topic I like to talk about today. So we are using AI to improve our workflow, but we are not handing over all our tasks to the AI. And then there is this real vibe coding thing, the vibe coding, the true vibe coding. Build me an entire application or feature, but the code that it generates, I don't care. So this is not what I'd like to talk about today. And maybe God vibe coded the universe, I don't know. I thought it's a nice meme. So I said I want to take a look into some numbers, because I like numbers. This is why I'm liking to wear fitness trackers. And when you Google around some productivity claims, you will find some really, really high numbers. For example, here, these are the most common numbers you will find. For example, GitHub Copilot claims that users are completing their tasks, also not just writing code, their task, 55% faster. That's a lot, of course. Amazon also claims that their AI tool called Code Whisperer was able to migrate Java code from an older Java version to a newer one by reducing the time by 57%. Also really big number. And Cursor users, and this is an interesting number, we will come back to that later, claim, so it's not Cursor itself that claimed that number, but the users, that they are 5 to 10 times more productive with the help of Cursor. So those numbers are looking really promising. But when we take a look into some other numbers, I called it the 100 million paradox, we can see now, okay, more and more developers are using those tools. So of course, the valuation of those companies rising up. For example, Lovable, I showed you the short live demo before, was reaching 100 million ARR in just 8 months. So that's a lot. Cursor 500 million, GitHub Copilot 400 million. Yeah, okay, cool. So looks like AI is here to help us. But when you take a closer look into the adoption rate of AI in companies, then we find those numbers, and they are less promising. For example, based on the resource, of course, 95% of AI pilots fail. So they don't earn money, or they don't help their companies to achieve something. 41% of the companies already have done most of their AI initiatives. And the next number is also interesting. Maybe you heard already this number today. There are some talks I take a look at in the live stream before, they already talked about this, is the so-called meter study. And this study is really interesting because 16 experienced open source developers should solve 246 real tasks with the help of AI. And the interesting thing is that they were asked, okay, try to predict how long you will take for the task without AI and with AI. And there is the result. So on the left side, you can see the forecast they made. So without AI, they thought about, okay, we need 2 hours. With the help of AI, we will save 20% of our time. And the interesting thing is, of course, the result. We can see that without AI, they were nearly reaching their estimated time. There's also something interesting. So we can see that advanced developers know how long they normally will take for a task. There's something also good. But we can also see the gap on the right side. With the help of AI, they were 19% slower. So this results into a 30% gap. So this is really bad. And they were allowed to use Cursor and Cloud Sonnet 3.5. So this was the best LLM out there when they created this study. So this sounds also not promising. There are more bad numbers I like to talk about. And there's also this Git clear analysis report. So Git clear analyzes millions of lines of code publicly available on GitHub. And they created this result. So we can see the so-called code churn increases or doubles in 2025. Copy-pasted code, nearly 50% increased. Code refactoring declined. This is something interesting because I like to use AI a lot to, for example, refactor an old Angular application from an older SDK version to a newer one. But looks like people stop refactoring existing code. And what's also interesting is the so-called DORA report. It's the State of DevOps report by Google. They release this report once a year. And because I like to see how companies like Google or Meta are adopting AI, we can also see that the code quality or the stability of the delivered features are decreased by 7.2%. Also not that good. More bad numbers, security nightmare, because there are so many tools out there that claim with help of AI they can generate more secure code. So I found it interesting to take a closer look. And this is the newest study from Code. And when you take a look into this slide, you can see from left to right, they benchmarked multiple LLMs over time. So when a new LLM was released, they benchmarked it with the same benchmark. And you can see that there are 2 lines. There's a gray line, and there is a colored line or multiple colored lines. And the gray line shows you that the syntax of the code is now nearly perfect. So we can say that the code produced by LLMs is compiling. But when you take a look into the security results, you can see they are not really improving. So nearly half of the code is failing when you benchmark against the top 10 OWASP tests, for example. So this is also not looking good. So why should we then use AI coding tools? That's the question. So from my perspective, there's a gap between the productivity claims and how developers at the end are using those tools. Because I don't think that AI is stupid and not helpful, and I also don't think that developers are stupid. Because when we take a look into this meta study, we can see they are able to solve tasks faster than AI. So it looks like developers are better. My claim here is that developers are not aware how to set up their AI coding tools, so they are actually helpful. So this is the next part of my talk. I like to show you how I set up my tools, so you can maybe try it out after the talk to gain more productivity. And first we have to talk about limitations, because it's also interesting when I talk with clients, they like to try something out with AI. They often still don't know what's the difference between generative AI, LLMs, and machine learning, for example. So the first thing, of course, is we have to understand that LLMs were trained with older data. So for example, when you ask GPT-5 released a few weeks ago. What's the latest Angular version? It will answer Angular version 18. The current version is version 20. So there's a 1 year gap between the current APIs and the APIs open API trained GPT-5. So it's a big problem. So of course, developers are then frustrated, especially with Angular, because I work a lot with Angular. When I talk with Angular developers, they say, okay, we don't use any AI tooling because they only use grep code. They use older APIs because the framework changed a lot over the last releases, so we cannot use this tool. Another topic that's important is that LLMs are unaware of external sources by default, of course. One example, try to ask ChatGPT, what time is it? It cannot answer, because how should it know which time is it? So how should an LLM know your coding standards, your architecture, your domains, your internal knowledge of the company? Of course, we need to help an LLM to get access to those data. And another problem depends on the LLM, on the task. Of course, we have to write good prompts. And normally I say, okay, developers are not lazy, we are efficient, so we don't like to write those long prompts, of course, but we should define those long prompts, because more we define in our prompts our goals and tasks, then the better the result, of course, is. And another thing I will talk about it later is the so-called context window. This is often also something developers are not aware of. Okay, so how to solve those issues, and I'd like to show you 4 to 5 solutions. The first solution is really simple, and it's called custom instructions. Those custom instructions help you to simplify your prompts. And you can see here on this screenshot on the right side, this is one custom instruction file, in this case for GitHub Copilot. And those files are just plain text, markdown files. I see it's ending with an .md. And in those instruction files, you can specify multiple things. You can specify how should the LLM work, how should it respond, which task should it do when you're using a reasoning model, for example. You can add domain knowledge into those files. You can define some APIs it should use, and so on and so on. And the cool thing is that those instruction files will automatically be added to all your prompts. It depends on the tool you are using. I will talk about that in the next slide. But normally it works with all tools out there. And often there's a question how to generate those files. So when you don't have an instruction file created yet, the simplest thing is just ask the AI to generate those instruction files. For example, you can tell GitHub Copilot or any other tool, hey, here's my ESLint file, my prettier file. So these are the files you normally use in the front end to define coding standards. And please create an instruction file based on that files, or review the current architecture, or write me an instruction file defining which dependencies we are using. When you're working on a greenfield project, sometimes a bit more complicated, then there are multiple tools out there. When you Google it, GitHub Copilot instruction template, for example, you will find multiple applications out there, websites, where you can copy-paste some instruction files created by the community. And what's also important is those files should be updated continuously. So normally you start with the first iteration, you try them out. The results are now maybe better, but not perfect, and you improve them. And there's currently only one problem, because there are so many tools out there. So I like to use Cursor, for example, and Cloud Code. Other developers like to use GitHub Copilot or Cursor and Windsurf. And the problem is that those files, those tools use different file names for those instruction files. So there's an initiative introduced a few months ago. So now there's a file called agents.md. So you place this file in the root path of your project, and then nearly all AI coding tools can use this file or will use this file as extra context when you prompt something. You can go on the website of agents.md and you can take a look if your favorite coding tool is already supported or not. For example, GitHub Copilot added support a few weeks ago. Okay, let's show you a short demo. So in my examples, I'm always using GitHub Copilot. Later, you will find also a QR code to find this demo repository, because GitHub Copilot has so many features, also Curse and the other tools, that I created this repository trying to demonstrate what can be done today with AI coding tools. So to keep it simple, and this is an Angular repository, but this does not matter. The most important part here is the subfolder or the folder.github. And inside this folder, then you find another folder called instructions. And inside this instruction folders, you find multiple instruction files. And because this is an Angular project, you can see I defined multiple files, for example, for Angular itself, for Angular testing, so generating unit tests, Angular material, the UI library, also for the signal store, so this is the store management library used in Angular projects, and so on and so on. And let's take a closer look here. And what's also interesting to know is those instructions file can be scoped. So it's important to understand that less is more. So when you use an LLM, of course you want to add as much context as possible. But for example, when you are working in a CSS file, why should you add context or instruction rules defining your TypeScript best practices? This makes no sense. Then often the result of the LLM is worse than before. So this is why you can also scope those files. For example, now this Angular instruction file is only used when I'm working with a TypeScript, HTML, or a CSS file. And to demonstrate this is working, I can now ask Copilot, let's go to the ask mode, just to demonstrate, explain me the app component TS file. And then we should see that Copilot is now using 7 references. So it uses the file of itself, what I tagged here, of course, but it's now also using those instruction files I defined in my project. And as I said, this also works with all other tools out there. It does not matter if you're using Cloud Code, Gemini, CLI, Cursor, Windsurf, yada, yada, yada. Okay. That's the first thing you should set up when you start working with those tools. The next thing is the external context that we need to add to our prompts. And this is when we take a look into the MCP protocol or MCP servers. And for those who are not familiar with MCP yet, it's kind of new, but more or less now a standard when it comes to workflows. You're using external data sources. It's developed by Anthropic, so the company behind the cloud models. It's a really simple SDK you can use that provides a consistent way how LLMs can then interact with external resources. And it's following a client-server architecture. So it's really simple. We have our clients, Copilot, for example, or Cloud Code, and our servers then are our external resources. And this can be your local time server as the simplest example, or your database, your file system. And what's also interesting, your external data provider like GitHub.com or the Atlassian cloud. So because I'm working a lot with Atlassian projects, normally they have a really huge Confluence documentation. Then I can use the MCP server in my AI workflows to fetch current knowledge from the Atlassian API, for example. And so there are official servers available these days for nearly all major providers out there. There are also a lot of open source repositories, of course, available. And a workflow can then look like this. Of course, this is just a simple example. I don't know, my CI pipeline failed. And then I can ask Copilot, okay, please fetch the latest logs of the CI, try to explain me the error, fix it for me, create a fix, push the code to GitHub, and then check again, is the CI failing again or not, as an example. But what is more practical for software developers is another MCP server I'd like to demonstrate. And this is the Context 7 MCP server as one example. So Context 7 is a free-to-use website. And this website is more or less just fetching multiple or thousands libraries out there and transforming the HTML documentations to plain text. And for example, you can take a look into the Next.js documentation, and then this documentation can be filtered for router. And then the context7 MCP server will return you the documentation about the router next, for example. So we can use this server to fetch the latest API definitions of any library you are using, because you can also set up or sign up here on this website and push your own tiny open source library, for example, to this website, and then fetch the documentation in your workflows. And to demonstrate, create me a page using the Pokédex API to display a list of Pokemon as an example. And also the cool thing is, for those who are not familiar with MCP tools, encoding tools, is that when you define an MCP server can then define multiple tools you can call. And then the LLM will select the tool based on the instruction, but sometimes this can fail. So the cool thing in Copilot is you can use, again, the hashtag, and for example, tag directly the context7 MCP server and the Angular CLI MCP server. And then Copilot will automatically call those MCP servers. So let's run this command. It should not take that long. And then we should see that GitHub Copilot is now calling the context7 and the Angular MCP server to fetch the best practices about Angular, because it's an Angular project. It also should fetch the Poke API library we can see here. So here we can see it's just a text return from the from context7, returning us the content of the library. So it's just plain text. That's nothing special. But this text is then used as context for the LLM to go on with this task. So we don't have to wait until this is finished, because this will take a while. We can also see Copilot is now taking a look again into our instruction files to understand the best practices, how I want Copilot to structure the code. It should follow domain-driven design, and so on and so on. I think we can leave it in the background here. Because there are multiple MCP servers out there, I cannot tell you which MCP servers should be used by you. Depends on the project. But there's, for each task, there should be a server available. Normally, I'm using, as I said, GitHub, Atlassian, context7, and Postgres MCP servers, for example, to be able to interact with my databases. There are more things I'd like to talk about. And the next thing that is also important is how to choose the right LLM. Because there are so many LLMs out there, sometimes it's not that easy to validate which LLM should I use for which task. How do I know if an LLM is good for coding or not good for coding, or too expensive or too slow or whatever? And there are multiple questions we have to think about. First, the performance at all, of course. We have to think about reasoning versus non-reasoning. We have to take a look into the so-called context size. Maybe there are some benchmarks we can take a closer look at. And the costs, of course. How much do we have to pay for input and output tokens? And I created this table here. Of course, when you maybe watch the talk a few weeks later, maybe there are some other LLMs released that might be better. But we can see here on the left side the model name. The provider is not that important. We can see nearly all models are supporting reasoning these days. And then we can see the context window, SVE bench, and 1 million tokens columns. And these are the important columns. And the first column is the context window column. And why is this column important? So an LLM is not working with plain text, so we have to translate our plain text into so-called tokens. To keep it simple, how many lines of code can be passed into an LLM? Because an LLM is working like that, so for each new token we generate, we have to take a look back at the tokens we generated before. So we cannot store endless data, of course, in our LLMs. And we can see the context window differs a lot based on which model we like to use. For example, the currently best models for coding, GPT-5 and The Claude models only support 128,000 to 200,000 tokens, and the Gemini API, for example, supports 1 million tokens. This is not also one thing that's also problematic is that it also depends on which API provider you are using and which tool you are using. Then, for example, the Anthropic API supports 1 million tokens, but only when you use the API. Maybe you use ChatGPT API directly, then you can also use more tokens. When you use Cursor, there's a max mode, so you can also add more tokens. So you have to take a closer look in which tool you are using. So currently, it's not that easy to oversee how many tokens can you pass to an LLM. But I tried to simplify it here on this slide. So when you want to take or put a lot of data into an LLM, normally I'm using the Gemini 2.5 Pro model. The next thing that is, of course, important is the software or the quality of the code those LLMs are generating. And there is a so-called SVE bench. And this is the official benchmark the LLM providers are using to demonstrate that they have a really good LLM in coding. And those numbers are also validated, so they cannot just claim those numbers. They are validated by the people behind the SVE benchmark. And you can also take a look into this column. And then you can see, for example, GPT-5 High, because there are multiple GPT models, so they're using reasoning, has the highest number. But when you compare it, for example, with the Claude models, there's not a huge gap between. But this number is really important because it's when you, for example, generate 1,000 lines of code, and then there's a 10% gap in code quality then you will have 100 bad lines of code. This is, of course, a big problem. So this is why it's important to take a look into those numbers. So when you work in a task and you have some complex data and you want to make sure the code quality is high, then, of course, you should choose a model that is way up top on this SVE benchmark. And the last question, of course, is pricing. This is also depending on which provider you are using and which tool you are using, but there are also big gap, of course, between some models. For example, Claude 4 Opus is really expensive with $15 input tokens, and compared to Kimi K2, for example, that costs only 13 cents. So there's a really big gap, of course, between the costs. So this is normally the numbers I compare when it's time to choose a model for my coding agents or coding tools or any other LLM work I have to done. Then there's something about prompt engineering. I want to keep it simple because the cool thing is now with those custom instructions we already defined, this topic is really simple. And because there's the CoStar framework that defines how you should write good prompts. And the C and the O stands for context and objective. And then we have style, tone, audience, and response. So style, tone, audience, and response is already defined in your custom instructions because they tell the LLM how should the code look like, in which patterns the reasoning model should work, the experience level, like you are an expert in Angular, and also the format and structure requirements. Also the context, the project background and constraints. This topic is also done by custom instructions or our MCP server. So we can also help the LLM to get those external context data about our project or our internal domains. So the last thing we have to prompt now is the objective, of course. So we have to define what's our goal and what's our success criteria. So we can say, okay, it's really simple now to prompt. We don't have to write those long prompts anymore because we defined our custom instructions. And what's also interesting, I only have this slide here about this because it was just released a few days ago, so I had no time yet to prepare a demo, is so-called spec-driven development with AI. And the goal is that the specification is here the important thing, and code is just a result of our specification. So you create those spec-driven files or definitions to tell the AI at the end what you like to achieve, and then following this pattern or framework, the code quality should be much better. As I said, I had no time yet to prepare a demo because it's a really new thing, but you should try it out, of course. When you have your own coding agent, for example, you can use this pattern to achieve better coding results. It's an open source, it's an open source library you find from GitHub. So you also find all links and all sources on the left side on my slides. There's another thing that's really important. Maybe for you it's nothing new, but when I work with our clients often, they don't have any static code analysis. So I showed you those bad numbers before with code duplications or security issues. So it's really important when we work with AI-generated code to set up quality gates. And so in the front end, for example, is always ESLint and Britia. And then in the CI pipeline, I normally like to add something like Sonar Cube or Sonar Cloud when it's not self-hosted, or the SaaS tools to do static code analysis, because these tools are really good into seeing, okay, you added duplicated lines of code, or you missed to add some unit tests, or you had added some typos, and so on and so on. But there are also some AI-optimized or powered tools you can use. For example, when you have a GitHub Copilot license already, you can use GitHub Copilot on github.com to review your code. This also works with the Gemini CLI and with Claude Code, for example. And this is really helpful because I have some startup projects I'm working together with them. So they have a really small team. Normally the developers are outsourced to India or nearshore to some Eastern European countries. And we set it up, those AI-supported review tools, and this helped us a lot to find some errors like this. There's a typo in the file. So because it's free to use, it's also something I can recommend to add to your pipeline. But at the end, it's important to stay in touch as a human, so human in loop. It's really important that we are reviewing the code those tools are generating. So this is why I'm not a fan of wipe coding and ignoring the code at all. So here's my best practice checklist you should try out after my talk. Define this custom instructions and files and rules. Depending on the tool, you can also use this agents.md file. Configure your favorite MCP server. You can also take a look later after my talk into my demo repository. There's an mcp.json file, for example. You can see how I configured my MCP servers. Then, of course, you have to take a look which LLMs you are using. Then when it's coming to generating code, then use this CoStar framework or pattern, how to define your prompts. As explained it before, you don't need to write now these long prompts anymore because of this custom instruction thing. And at the end, the most important part, of course, is taking the quality high by introducing those quality gates. So the future we are building, prediction versus preparation. I assume that more and more autonomous coding agents will come in the next couple of months and weeks. So this trend is invincible. So I will not say that we will never write code by ourselves anymore. This is why I'm critical about this wipe coding thing. But I assume that more and more code will be generated by AI in the future, and we are maybe only the people that oversee the results and refactor them, or giving those AI systems maybe feedback. So this is why quality gates are so important. So the critical decision we have to do today. How do we maintain the code quality in the future? What skills should we develop as a human? And as I said, how to ensure code quality, security, and also privacy stays high. So my call to action is try out those tools, because I know a lot of developers that are never played around with AI coding tools. I don't know why, but sometimes developers, they don't fear that tools, but they think they will not help them to get better. When you take a look into this meter study, maybe they are right. So try them out, play around with those instructions in MCP servers, and invest into prompting to understand how LLMs work, so you are able to use this technology in the future. Because, this is my last slide, I think the best developers won't be replaced by AI. They will be the ones who learn to wild it. that's it from my side. Thank you for your attention, and yeah, thanks. Slide? Yeah, can you? Yeah, on this last slide, you find this QR code to my socials. You can also find my GitHub repository. You will also find the slides. Feel free to ask me questions about this AI coding topic or anything about AI itself. And yeah, thanks. Oh, the result? Yeah, let's take a look back, because we have a few minutes left. I think I have to press continue. But I tried it out before I went to the conference, so it worked. But let's see. Maybe I start the result. Give me a second. I think I have a few seconds left. Stop, because I already tried it out before. Here should be the result. No, I stashed it, sorry. I stashed the result, I think. Move, 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 and stash, apply. I think this was the last stash. Let's see if it's working. But I think it worked. Localhost and Pokédex. It worked. Yeah, there's no detail page, but it worked. So it was able to fetch the API specification, created top-notch Angular code. So it worked. Yeah. Okay, thank you.